Alright, so this is lesson 1-6, which is over two-dimensional figures. So, some vocabulary. A polygon is a closed figure formed by a finite number of coplanar segments called sides. So, what this means is that there is no polygon that has an infinite number of sides. And if there was one, we would consider it to be a circle, but circles are not polygons. And all of those sides must be in the same plane. Now, those sides must have a common endpoint that is non-collinear, meaning that that endpoint can't be somewhere over here, where if M had moved over here, those 3 points would be in the same line. Therefore, that side would be GM would actually be eliminated. And each side must intersect at exactly 2 other sides, but only at their endpoints. So that means that each side should intersect 2 other sides, but it won't intersect in the middle of that side. Now, the vertex of each angle is a vertex of the polygon. So a polygon is named by the letters of its vertices, and they are written in order of consecutive vertices. So if you start at point G, you should be able to go around and come right back to G. So they name this G, H, J, K, L, M. Now, you cannot just skip around. So you can't say that it's G, J, L, M, K, H. But you can start at G and go the opposite direction, or you can start at H, J, K, L, and M, as long as you are following a circular pattern. This table shows some additional examples of polygons and some examples of figures that are not polygons. So all of these are examples of polygons. These are non-examples. This one and this one are not examples because they intersect somewhere other than an endpoint. These 3 have curved sides, and in order for them to have curved sides, they would have to have an infinite amount of segments, and this is not a closed figure, so therefore it cannot be a polygon. Convex versus concave. Polygons can be concave or convex. So what you want to do to tell the difference is you're going to draw lines along each line segment, making them actual lines, meaning that they extend on in all those 2 directions infinitely. If those lines intersect the middle of that figure, then it is a convex, or if it intersects the inside, then it is going to be considered to be concave. If it does not intersect the inside, then it's going to be convex. So this is a concave figure, this is a convex figure. I like to think about it as concave, meaning that if you were to smash it, it would cave in on itself. So in general, a polygon is classified by the number of sides. The table lists some common names for various categories of polygons. So a polygon within sides is called an engon. So here's the traditional examples. You have a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, and dodecagon. Now, an 11-sided figure, I've never actually used this name formally, so that would not be one that I would expect you to know, but I would expect you to know the rest of them. Otherwise, if it has a number of sides, then you just call it that number of sides and then gon. So a 15-sided figure is a 15 gon. An equilateral polygon is a polygon in which all sides are congruent. So you can associate sides with lateral. An equiangular polygon is a polygon in which all angles are congruent. So you can associate angular with angles. So A convex polygon that is both equilateral and equal angular is called a regular polygon. So that means that in order for a polygon to be regular, it has to be convex, it has to be equilateral, and it has to be equal angular. Okay? And if one of these three things doesn't happen, then it's going to be considered to be an irregular polygon. An example, this is a regular pentagon because all of the sides and all of the angles are congruent. A irregular pentagon is, if I were to draw a house type shape, because that has the same number of figures, or same vertices, but it does not have the same number, or it does not have the same angle measures. Alright, so if I name this example asks me to name each of the polygons by the number of sides and then classify it as convex or concave and as regular or irregular. So in this case, this is a hexagon because it has 6 sides. And if I were to draw in these lines here, right here you have 2 lines that intersect the interior, so that makes this a concave figure. And it is irregular because all the sides are the same, so it's an equilateral, but all of the angle measures are not congruent. This, however, is an octagon because there's 8 sides, and if I were to draw in all of the sides, which I didn't on this one, it would be convex because they would not intersect in the center anywhere, and it would be regular because all of the sides and all of the angles are congruent. So I want to encourage you to pause the video and look at and see if you can do these on your own, and then when you unpause it, you can check your answers. I'm going to go through those now. So 1A is a quadrilateral because it has 4 sides. If you said rectangle, a rectangle is a special type of quadrilateral, so it's kind of acceptable, but we won't get into those definitions until a later date. It is convex because those lines would not intersect on the interior, and it is irregular because although all the angles are the same, making it equal angular, the side lengths are not, so it is irregular. 1B is a decagon because it has 10 sides. It is concave because if I were to draw in those lines, there would be several lines that would intersect the interior of my figure. And it is irregular because although all of the sides and all of the angles are actually congruent, in order for it to be regular, it has to be convex. 1C is a hexagon because it has 6 sides. It is convex because if I were to draw on all those lines, none of them would intersect the interior, and it is regular because all of the sides and all of the angles are congruent, and it is convex.